Hey everyone, welcome to another Diagrid webinar. This time we're talking about building reliable agentic AI apps with Aspire, Microsoft Agent Framework, and Catalyst. And we're not going to say Microsoft Agent Framework all the time, we're just going to say math, because it's just like too many words. All right, it's time to get started. So this time I'm not presenting this by myself, but with me is Whit Waldo from Innovian, and also he's one of the .NET maintainers of the .NET SDK. So yeah, warm welcome to you, Whit, and thank you for co-hosting and co-presenting with me. And yeah, you're starting with this webinar, so go ahead.
Okay, great. Well, hi. As Marc said, I'm Whit Waldo, CEO of Innovian. I guess we're going to talk about a framework that I built, and then I guess Marc is going to wrap up with a demo, pairing it with Aspire and running on Catalyst. So I guess this is meant to be more of a beginner or intermediate session. If you have any questions, of course, drop them in the chat, and we'll be happy to answer them. So we've seen lots of impressive agent demos, but there are serious gaps once you move into production. You may have an agent that gets halfway through a 5-tool workflow. It restarts. Progress is lost. It resumes again. Every time you're calling that LLM, is costing you money. When you lose state, you have to re-execute everything from scratch. You potentially don't have any observability. You need to know what the agent did, why, which agent even ran. And most agent frameworks kind of assume that every time it runs, it works. So there doesn't tend to be a whole lot of fault tolerance. So how do we bridge this gap? Well, first, let's talk about math, or the Microsoft Agent Framework. So for anyone unfamiliar, it's Microsoft's next-gen agent framework. It takes two previous frameworks, the Semantic Kernel and AutoGen, and kind of combine them into one. It just recently GA'd last month. So it's no longer considered experimental and is considered production ready at this point. It's model agnostic. It's not locked to Azure, OpenAI, Anthropic. And it supports .NET and Python. This library that we'll be talking about today focuses on the .NET side. It supports workflows internally as a first-class concept, but we're going to talk about replacing those workflows with Dapr itself. So there's two building blocks that are important here. We've got Dapr Workflows and we've got Dapr Conversation. The Workflows is a durable execution engine. Unlike the one built into Math, this one, it works differently. Every step is persisted. If the process crashes, it's able to pick up where it left off. Because it's built on top of virtual actors, it is atomic operations. So as different processes in the operation complete, that is persisted, so that if if the workflow fails, it's able to resume back into where it left off and keep on going without necessarily having to start over from scratch. The Conversation API is an abstraction for various LLM providers. Again, OpenAI, Anthropic, even Ulama. It's completely transparent and optional. If you don't want to use it, you're not required to. You just need something that implements the iChat client from the Microsoft Agent Framework. So they're overloaded. So it means that you're not locked into the Dapr's kind of built-in routing if you don't want to. Do note that both Workflows and Conversations requires version 1.17 of the Dapr runtime. Otherwise, it's not going to work. So what happens when you combine Math with Dapr Workflows? So this is the tool that I built. The core idea is take Math as the agent abstraction, but run all of the execution on top of Dapr Workflows. So every call into an agent is a workflow. Every call to another agent from that agent is a child workflow. Every tool call is an activity. And they themselves are able to call workflows, and workflows are able to call agents, and so on. If a process crashes, the workflow engine just picks it right up and resumes from there as though it's workflow. You don't have to, where you could use Dapr workflows and write a lot of this stuff yourself, directly. This is an abstraction that, really simplifies all that. That you write normal math code and you just say, run them. And under the hood, they're running on top of workflows instead. So let me show you kind of how this looks, more architecturally. So a user request is going to come in. The math agent is going to receive it and begin reasoning about what to do about it. It passes that into Dapr Workflow to orchestrate it. If there are any tools, it's going to execute each of those as activities. If it needs to call, other agents, that is going to call into the Dapr Workflow orchestration again, because again, it's going to run those as child workflows. And then it's going to pass that out to the LLM via either the Dapr Conversation API or through the iChat client that you provided. And so, it handles nested orchestration as deep as it needs to go. All the child workflows, as in Dapr, are independently tracked and recoverable. The replay is safe, the state's persisted, it's entirely transparent. So what do you kind of get from this? Again, it's built to kind of tackle the problems that we addressed earlier. So you're going to get the durable execution. So that's the big one. If it crashes, it resumes from that last activity, not from scratch. The LLM itself may be probabilistic, but the workflow engine is going to be predictable. So it's deterministic orchestration. It's, every time the workflow runs, it's going to run the same way. Again, and because the state from previous agent executions is persisted, it's not going to go and take a different path when it goes and replays after a crash. It's, going to use the persisted output and take the same path, at the next point. So you always know what step you're on, what's completed, what's next. There's, basic math stuff. It's not, it is model agnostic. There is no dependency on any given model provider, and it's native.NET. This is not a Python framework with .NET wrapper. It is, C# with proper DI, .NET 8+ support. So there's kind of two ways of integrating with LLMs. Both of them are fully supported via the various method overloads. One way is to go through the conversation API. You pass in the name of the component, so you'll define that as you would any other Dapr component. And if you look at the examples in this project, they're all going to use this approach. You create any number of conversation components that you need. You're going to pass in the name of which component it is that you want to use and assign to which agent. If you need to swap out models, it's a config change, not a code change. Or if you want to implement your own version, I think Marc's demo is going to show path B here using an iChat client. So you can bring your own. Again, overloads exist for that. Use any provider. Anyone who implements iChat clients, will work for this. An obvious caveat: if your workflow is going to call tools, you're going to want to use a tool calling model. The framework doesn't know anything about the model that you're calling. It's simply passing it through to the LLM. So it won't stop you if you don't use a tool calling model, but it's likely not going to work very well. It's just, frankly, it's in my testing, it's just going to keep apologizing at you. So that's not going to be helpful. So, what can you build with this? A bunch of things. The simplest point is just an agent. You register an agent, you give it some instruction of what to run, you pass in input, and it's off to the races. You never will see anything about Dapr workflows. They will run entirely transparently underneath. Works with or without tool invocations. If you open up the Catalyst and you're monitoring the process, you'll see each of the steps happen, even though again you never registered a Dapr workflow at all. You can run agents with tools, and add tool functions. Each of those will then run as a durable activity. If again any of those crash, it's fine. It'll pick it up and replay like it would any other Dapr workflow. And multi-agent, so one agent calling another, they become child workflows, again, independently tracked, independently recoverable, and infinitely nestable. And so, especially if some some call to an LLM is taking a really long time to complete, that's fine. Especially in a multi-agent workflow, you could have kicked off multiple child workflows where they're all doing different tasks, and they're all going to complete at their own timeline. And again, tracked as just a Dapr workflow. Kind of worth mentioning, the library also supports JSON serialization of agent responses, so that you get kind of built-in type safety. Again, there's a lot of examples for each of these things. But yeah, there's kind of two directions of composition that we're looking for. So demonstrated here, the left side, workflows drive agents. So if you're familiar with Dapr workflows, you've got the workflow context, and you largely drive anything inside the workflow from that. There are now methods where you can, because you can't inject anything into a workflow, the methods allow you to, in the same manner in which you're able to create a replayable logger, you're also able to access agents and then also run agents from within a workflow, similar to, again, how you'd set up a child workflow. And then again, the agent just becomes another activity or another workflow alongside the rest of your deterministic business logic. So this is great if you can have a series of different steps where some of them are LLMs, some of them aren't. On the other hand, you could have the agent itself drive workflows. Maybe a tool is going to kick off an entire Dapr workflow. It's going to feed that result back into the agent's reasoning loop. You could have agents in workflows call agents, which also call workflows as low as you want. All the nesting's managed transparently by the library, and again, it runs like any other Dapr workflow, but in a way that you never, unless you want to include the workflows and build against them, you don't have to do anything. You don't manually track any of these workflows. The library's going to handle that for you. So, what are we working on? What's next? This last week, I shipped session support. So we have implicit sessions. If you want to create a session just like you would in math, pass it into any call into an agent, and it will, as each turn completes, it's going to persist that in the session, so that as you call into another turn, it passes all the turns that have happened so far into the next call. So the classic example is the ongoing chat conversation. But it also supports a more explicit messaging. So if you want to only pass in some of the messages into different agents, you can kind of pick and choose which of the messages from which turn you pass into other agents. There are 3 demos in the examples that kind of show each of these different scenarios. Let's see here. Otherwise, you can run this locally. You can run this on Diagrid Catalyst. If you don't want to run Dapr yourself locally, Catalyst can handle with that. And I think at this point, I'm going to pass it off to Marc.
Yes, thanks, Whit. Right. You can leave the screen on if you want. If you can keep sharing this, that's be perfect. All right. So we will be using Catalyst for the demo that I will show in like a minute. And if you're unfamiliar with Catalyst, so Catalyst is an enterprise platform that allows you to run your agents in a very secure and reliable fashion. And that's because Catalyst is built on top of Dapr Workflow, which provides the durability of your agentic systems. So as you can see here in this diagram on the left, you have all of your agents, Diagrid Catalyst here in the middle, that's running your workflows, that has like built-in observability, built-in session management, and also MTLS, so communication between agents and other resources is secure. And with Diagrid Catalyst, you can actually connect all of your infrastructure also in a secure way. So you can safely connect and communicate between your agents, but also between your databases and MCP servers and other external tools that you'll be using. All right, let me take over now, because now it's time for the demo. All right, we can get out of this. So I'm switching now to VS Code. And by the way, I'm going to share all of the resources because this is a publicly available GitHub repo that contains this solution, so you can actually try this yourself. So what we are going to do is we're going to run an agentic application that's using Aspire, using .NET 10, it's using math agents, and we are running this with Catalyst to actually demo the durability of these agents. So if I just show you what kind of things we're using here, .NET 10, Aspire, Diagrid Catalyst, we're using math, and this is the library that Whit just introduced, right? So the agent framework is actually providing the glue between math and Dapr Workflow and Catalyst. In this case, I'm also using OpenAI with the GPT-4o mini model. If I just show you what the agentic workflow is doing. So it's actually starting 7 individual diagnostic agents in parallel. So it's like a sci-fi themed thing. We're going to do a diagnostic of the USS Enterprise, and all of these agents will check the hull integrity, it will check life support, it will check the warp core, the shields, the weapon systems, the navigation, and the transporter. And then the workflow will wait until all of these agents have been completed. And by the way, all of these agents are using a tool as well. And when all these agents are completed, we are calling another agent, which then determines the priority based on all these diagnostics, because some things might be failing and in a bad state, so those need to be fixed first. Then we will call another agent to summarize all the diagnostics. Then we have some business logic in there in that workflow that if the priority of any of these agents is like immediate, that needs immediate attention, then we also send an alert to the bridge. And this is a regular Dapr workflow activity. So this is not an agent, by the way. So this is also like a nice example how you can actually mix and match both agents and activities inside a workflow. All right, let's show the code. So since this is an Aspire project, there's always an app host that you're using. So this is the app host configuration. As you can see, it's quite minimal. There's not a lot going on here. The most important thing is this: we are adding a Catalyst project. So there's a NuGet package that you can install, which allows you to configure Catalyst in your Aspire project. You need to give it a name. So this is a project name that we'll see in Catalyst. And you have to make sure that enable managed workflow is true, because we'll be relying on this workflow feature. All of the workflow state will be managed by Catalyst. And then we have our project, our API service project, and that's using Catalyst. And we also set an environment variable with an OpenAI API key that we'll be using for the agents to use. If we look at the program CS of the API service, where the registration gets done of the agents, that is done right here. So we can see that we create an OpenAI client in this case. And so with mentioned, you can either use the Dapr Conversation API, or you can create your own iChat client. In this case, I'm using the OpenAI client. You're probably most familiar with that if you're using math. But yeah, please try also the Dapr Conversation API, because it's also like very versatile. So this is how you configure tools. So there's an array of diagnostic tools. In this case, there's only one. In this case, it's a very basic one. It just generates a randomized percentage that I'll be using, because we're going to ask these agents to come up with some diagnostics, and all these diagnostics have some numbers, and this tool will actually generate these numbers. Then there's the registration of the actual math agents. So we're using the add Dapr agents extension method here. I'm providing a context to make sure all the serialization goes all right, and we have like typed results later. Then we register the workflow, and I will show you the workflow in a bit. So it's the enterprise diagnostics workflow. We register the activity, the notify bridge activity that's called right away at the end if there's an immediate priority diagnostic that needs to be solved. And then we call the with agent for where we register actually all of our agents. So all of the agents, of course, have instructions, and these instructions are actually here at the bottom of this file. And so just as an example, so you are USS Enterprise Hull Integrity Diagnostic System, and we just use this tool to generate some data, and there are some rules involved as well. Like if the integrity is like below something, then it's like critical. So every agent has like a specific instructions. All right, then we specify the agent name and then the list of tools. And in this case, all of the diagnostic agents use the same diagnostic tool. So that's why they're all very similar. There's the prioritization agent, which doesn't use any tools. And there's the summarize agent, which also doesn't use any tools. So this program CS also contains some HTTP endpoints to actually start this workflow, which then kicks off all of these agents. So this is the start endpoint that actually schedules a new workflow, where we provide an input that just contains like a start date, and that's it. Okay, let's have a look at the workflow now. So here we have our enterprise diagnostics workflow. And this is the way how you can get your agents from the workflow context. So here we use get agent and then provide the agent name to retrieve it from the workflow context. So here we have all of our diagnostics agent and the prioritize agent and our summary agent. And this is then how you call them. So you do run agent and deserialize async, because in this case I want a typed result back. So that's why I run it, and I want to deserialize the JSON into a typed result here. So this is the name of the agent. This is the message that we're sending. Generate diagnostics for a certain start date, and make sure that we have like a proper JSON schema as a result. So here we are calling, this is actually not calling it, but here we are creating the tasks for all of these agents. So all of these diagnostics agents are configured here. And this is the part where we actually say to Dapr Workflow, in this case, Catalyst, now go on and actually schedule, start, and run all these agents, and then wait until all of them have been completed. So once that's the case, and then we also need an actual result, we have this diagnostics list containing all of our results from the diagnostic agents. Then we actually build a prioritization prompt with all these diagnostics and give that to the prioritization agent. Then some extra safeguards. Then we call the summarize agent to actually give a summary. And here's the if statement that is if there are some immediate things that need to be taken care of. In this case, we call the notify breach activity. Okay, so this is how the workflow looks like. So now let's actually run it. And I'm going to run it in two different ways. First, I do like the happy path. So what happens when everything goes all right. And in the second one, I actually show what happens if something is not working. I'll like introduce an error in the tool calling. Then I'll run it again, and then I'll show you Catalyst to see and to actually illustrate that Catalyst will keep retrying. But let's do the happy path first. So what I did before is I already used the Diagrid CLI to log into Catalyst. So I can now just simply start the application using Aspire Run. So let's do this. And then I will start the workflow by calling this start endpoint. And the payload is just a random ID with a start date. Okay, so Aspire Run is starting, and we have the dashboard, and the dashboard should be also live here. Yeah, so this is the dashboard as you're used to, and yeah, if you're using the Catalyst integration, you see this this integration here in the resources page. And if you click this, you end up in Catalyst. I already have Catalyst open here already. In the workflows, but we'll get back here. But let's first call it. Okay, wait. Sometimes I have this weird socket hang-up, so I need to actually start the process again. And then I can make the call. It's probably do some weird WSL configuration on my machine. I'm restarting Aspire now, and then I'll make the call to the start endpoint. All right, so I'm now making the request. And we get back a 200 OK with the instance ID of the workflow. And that starts with 1D9. So let's look for an identifier 1D9 in Catalyst. We see a lot, but it's actually so much. Yeah, so this is the 1D9 right here of type Enterprise Diagnostics. It's running. So we click this. We actually see more stuff, and I'll explain that shortly. But let's first actually look at this. And well, yeah, it's already completed. So here you see the visualization of the entire workflow that's calling all the agents. And if I like zoom in a bit, then we can see what Whit mentioned earlier, that all of these agent communications and tool communications are wrapped in a child workflow. So this is an agent run workflow. So if I expand that, you can see that this is actually the transporter agent that's being called. And this is the user prompt that's been provided. And when we look at the output of this transporter agent, here we can see actually the result of it, but it also includes the entire turn messages, right? So when this was the user prompt, and then we see that an assistant is called that actually calls out for the tool calling, the get random percentage, and we see then the result of that random percentage. So that the tool is called twice because the result contains two numbers. So again, we see a call to the random percentage, and then we see the actual output of this assistant. So it's very nice. You can actually see the entire line of communication, what happened in this sub workflow that our main workflow here is calling. So you can see that all of these 7 diagnostics agents have been called, and then they go into this prioritization agent, again with all of its steps and its output. And then we see that the summarize agent is being called. And the final step is this notify bridge activity, because apparently there was one diagnostics that returned, okay, we need immediate attention here. Right, so this is the happy path. I will go back once more because to the workflow executions. Because what you see here in this list as well is we see this enterprise diagnostics, the 1D9, but we also see all of the IDs here of the agent run workflows, right? So your workflow history table gets quite full with this. You can actually select the root only. And if you do that, you don't see the child workflows, but you see just the parent workflow, and that's the enterprise diagnostic. So if you're doing this, it's actually quite nice to just make sure that you have this root only enabled. So it just cleans up your view a bit. Okay, so now let's go back to the code, and let's make a change in the code to actually force the tool to fail. And let's see what happens then. So I'm gonna stop this. And okay, so here we've introduced a failure in the tool, right? We're doing environment exit from inside the get random percentage tool. And since this tool is used by all of our diagnostic agents, all of these agents won't be able to finish their work. So let's try running this bad scenario. Let's see how it looks like in Catalyst, and then let's see how this can be fixed. So I'm going to do aspire run to start everything up again. And then we will start this workflow with this issue in there. Oh, that was too soon. All right, so now the workflow is started and agents will try to use the tool to finish their work, but yeah, they won't be able to. So we're looking for this workflow with 5.4D. So let's have a look at workflows, 5.4D. So we see that it's running here. So if we scroll down, so we can now see that, okay, this is weird, right? So we start our workflow, all of the agents have started their work, but yeah, they cannot finish it. And so they appear to be in running mode, and that's because, well, they're running inside a child workflow, and that's continuously trying to retry if it can succeed. But yeah, since actual code is wrong, it won't succeed. So these are now stuck. So let's go and fix the code, and let's come back here. So let's stop our application. Let's undo that error we introduced. So let's fix this. So now we commented this part out again. Let's rerun our Aspire application. Now we don't need to restart the workflow again, because the workflow is already in running mode. It was failing at the tool calling part, but we don't need to restart it manually. So Dapr Workflow and Catalyst is smart enough to realize that there's still work to do. So let's go back to Catalyst. And let's see the speeding results. Okay, so now we can already see that all of the agents have completed their work and that the workflow is actually continuing to execute. So this is the prioritization agent. This is the summary agent that's running now. And after that will be the call to the activity to notify the bridge in case there are any immediate repairs. So here we can already see that Catalyst is able to restore this workflow with all of the agent calls, because everything is wrapped in these durable workflows that will keep retrying in case of failures. So yeah, this is working as expected. Good. Okay, some other stuff I want to mention of why it's useful to have like a combination of MEF and Catalyst. So Catalyst runs in your Kubernetes cluster. So for a lot of people, they really prefer to have it like in their own cluster. And of course, their cluster can still be on Azure, but it could also be like another cloud provider or like even on premise. So with Catalyst, you are a bit more flexible than you would choose it to do it with just with MEF if you not necessarily want to run on Azure. Another one is the availability and performance benefits that you get with Catalyst. MEF, if you, for instance, use the Foundry agents that use the durable task scheduler service, and that durable task scheduler service is still very new and that's not available yet in every Azure region. So that could be an issue. And also, since you're running Catalyst in your own Kubernetes cluster, you would have also like lower latency and also some cost advantages there. So it's definitely something to think about. Finally, the agent communication and security itself, like I mentioned before, in Catalyst, every agent has its own identity, so that's very good. All of the communication also goes over MTLS, so that's also something you get out of the box. And the DTSS doesn't have like an agent identity concept, so that's also not available. And well, the nice thing of using MEF with Dapr and Catalyst is, of course, that you can get all of the other benefits of Dapr, right? You can use all of the other APIs like PubSub messaging and servicification. So it mixes very well with the other, let's say, common distributed patterns. Right, some resources and getting started. We'll have quite a list, of course. The NuGet package where to get it. So thank you very much, Whit, for building this. It does work indeed very nice. The sources at Diagrid.io/.NET AI, and actually I will also share these links in the chat. The demo repository that I was using, Diagrid Labs. So Catalyst Aspire MEF. Dapr Docs, I hope everyone needs Diagrid Docs, so docs.diagrid.io, where we explain more about workflows and agents. MEF Docs on learn@microsoft.com. But I also want to show you some other things that we are doing quite soon. So next week, there will be like a Dapr community call. So please go and watch that. And then the week after, we're doing another Diagrid webinar where we speak about agent identity. So I think Marc and Jeroen will host it together. Then if you want to learn more about Dapr, we have quite a lot of learning tracks on Dapr University. A new one will land the end of next week. And that is, I think, very good for all of you here because that will be about .NET Aspire and workflows. And last but not least, please join the Dapr Discord. We've just did a huge cleanup on the Dapr Discord and make it hopefully much nicer for new people to join there. And that's also a good place if you have questions about AI agents or workflows in general. So please join. Thank you for Whit for sharing some of the links. I will also put a couple of links in there. So I will.
I think I got the whole of the previous slide.
Oh, perfect.
Yeah, absolutely. Everyone, please feel free to open issues on the GitHub repo. If you have any features that you want to see added, if you're experiencing any problems, if you just want to just chat about it, please don't be shy. Love to hear how you're using it and how I can make it a better tool for what it is that you're trying to do.
Exactly. Yeah. And also let us know what kind of other agent frameworks you're using and might be interested in using with Dapr, because Dapr now has quite a lot of integrations with other agentic frameworks. So we're also very keen to also create like dedicated learnings for those. If I get a lot of feedback from we want to learn something about, in this case maybe MEF and Azure, well, that's definitely on the list. It definitely helps us to prioritize certain learnings over other things. So please let me know.
If there's something really advanced you want to see, Marc and I can absolutely put our heads together and come up with a far more advanced example we can give. So let us know what you're interested in seeing.
Exactly. Yeah, I still see a question from Samantha. So about the naming conventions used on the MEF agent workflows. So what's the naming convention used on MEF agent workflows?
I don't know. I don't understand the question.
Okay, we can take it offline. We can that's okay. That's okay.
I'll get back to you, Seth.
Exactly. We know who you are. Yeah. All right. Thanks everyone, and I hope to see you again at the next Diagrid webinar. Okay.
Thank you.
Bye bye.